I'm going to do this. So this question involves measuring, and if you're doing it on the original exam paper that's not been the scale's not been changed, or if you're doing it on the handout I made, it should work out okay. If you're doing it on a slightly different scale, like it's been shrunk perhaps, you might get a slightly different answer. So you'd have to check you're working for whether, at least you've got the method correct, which is the main thing, of course. Right, so when I measure it, I put my ruler on Newcastle on 0. We could do it the other way around. And on Cambridge, it is 4 centimeters. So if you didn't get 4 centimeters, you could still, you could pause the video and have another go and see if you now agree with the answer that I get. So 1 centimeter is 50 miles. To go from centimeters to miles, we therefore times by 50. And therefore, we're going to do that for 4 centimeters. 4 times 50 is 200 miles. Brilliant. We know how far he's got to travel. He drives at an average speed of 60 miles an hour. What time do you need to leave Cambridge? Right, we need to work out the time that it will take to go from Newcastle to Cambridge using this average speed and the distance travelled. So speed is equal to distance over time. Well, that's actually, that's the average speed, distance over time. So we can rearrange that to speed times time is equal to d, or time is equal to speed divided by, distance. I made a mistake there. Time is equal to distance divided by speed. In our case, time is going to equal 200. That's the distance divided by 60. Put that into your calculator. And we get 10 over 3, or 3.3 recurring. Or if you want to write it as a mixed number, press shift and that, 3 1/3. So it's 3 1/3 hours. So it's 3 hours, and then we need to work out how many minutes. Well, 1/3 of an hour is 1/3 of 60 minutes, and that is 60 divided by 3, so it's 20 minutes. You can see there are 3 lots of 20 in 60 minutes or in an hour, and therefore it's going to be 3 hours and 20 minutes. So if I've got 11 a.m. is the time it needs to get there, I can do 11 minus 3, and that's going to be 9 a.m. But it's got to be another 20 minutes before that. Sorry, it's not 9 a.m., it's 8 a.m. Apologies. 8 a.m., but it's got to arrive there 20 minutes before that, so it's going to be 7:40 a.m. Hey, good question. Yours, as I said, yours might be different, but yeah, if you go with the 4 centimeters that I did, that is the answer. State an assumption you've made and explain how this has affected your answer to part A. Well, here's a few possible assumptions. So we've assumed the route is a straight line, which it isn't in reality. It's going to, the roads are going to go a bit more over the place. It's going to probably be longer than 200 miles. And we're also assuming that he's taken no rest breaks. He's just gone throughout. I mean, you could argue, I suppose, that the average speed of 60 miles an hour includes rest breaks. So I'd say the straight line is a stronger reason. And therefore, or speed overestimated. So therefore, overall, the distance is probably underestimated and the time will actually take longer. So if he needs to be there at 11 a.m., probably needs to leave before 7:40, maybe 7:30, maybe a bit before that.